Thank you, Daniel. Today, I'd like to show you how to simplify configuring your server apps and libraries using a new package we recently open sourced called Swift Configuration. We'll follow a simple to-do app through its configuration evolution, from hard-coded values to production ready. We'll explore the problems at each stage, and then we'll dive into Swift configuration and how it can help solve these problems for the ecosystem. We'll see how both apps and libraries can use the same configuration API. And at the end, we'll touch on some more advanced features that can make operations much easier. Throughout this talk, we'll use this code snippet. It's a simplified version of the tutorial on swift.org, and it shows a Vapor service that stores to-dos in a Postgres database. Right now, it gets configured through hard-coded values only. The logger always emits logs at the info level. The server's listening address is for all interfaces on port 8080. The HTTP client's read timeout is set to 30 seconds. And the database is always expected on localhost on the standard Postgres port 5432. Hard-coding values is OK at early stages of development, when I might just be running my app locally on a single machine. But I'd like to deploy my app in a data center now, and the hard-coded values can quickly become a problem. For example, if all of our configuration is hard-coded, changing even a single value, like the log level, requires a full rebuild and redeploy of our service. In larger projects, a full redeploy can take hours, but during an incident, we need to be able to react in seconds. Hard-coding also makes it difficult to separate development and production environments. Ideally, I want to be running the same binary in both environments with just different external configuration. And in our app, the HTTP client timeout is a great example of a value that's really hard to tune. In the service we call might be overloaded and start producing much longer request durations. And if the timeout is hard-coded, we won't be able to react quickly, and we might even cause an outage for our users. So little fiddly parameters like timeouts are a great candidate for external configuration. So with all these problems caused by hard-coded values, the next natural step is to add external configuration manually. In our app, let's use environment variables first. For the log level, I'll read the value from the process info API, try to convert it into a valid log level, and if it's missing, still default to the info level. For the next few fields, let's use a YAML config file, because having too many environment variables can get verbose when you're running on the command line or setting up a scheme in your IDE. I'll define a decodable struct that represents the values I'd like to be able to override. I parse it using a YAML decoder, loading data from a file in my current working directory called config.yaml. Let's scroll that a bit. And let's update the server configuration now. First, the listening host name, then the port, and then the HTTP client timeout. And for the database URL, I'll use an environment variable again. So at this point, this is what our external configuration looks like. We override the log level and the database URL in environment variables, and the rest of the values in a YAML config file. So this is an improvement, but there are still problems with this approach. First, it's inconsistent. There isn't a strong reason why exactly these configuration values should be coming from these providers, and it comes down to a personal preference. That can lead to every project handling configuration completely differently. This approach also couples configuration keys with their exact provider, but a reasonable operator might need to override the HTTP client timeout using environment variables instead of a config file, because it's easier in Kubernetes. And partly because of this coupling, external configuration is mostly a feature we see in applications, but not nearly as much in libraries. But in our server app, all of the configuration values are being forwarded to libraries, to SwiftLog, Vapor, and Postgres. So to simplify configuration of server apps, we really have to simplify configuration of server libraries. This approach is also not observable. It's not testable. It doesn't handle secrets with care. And it requires restarting our server just to pick up new configuration. So these are the problems we set out to solve with Swift configuration. Swift configuration is a new API package for reading configuration. It allows both libraries and applications to use a consistent interface, and for operators to control where their configuration comes from in a single place in their app. It achieves this with two components: a configuration reader, a concrete type that has methods to read a configuration value for a given key, and a configuration provider, a protocol that's implemented by specific configuration sources. We offer several built-in configuration providers, such as environment variables, command line arguments, JSON and YAML files, and in-memory providers. But you can also implement your own custom providers to read configuration from any formats or sources that we don't support yet. Let's look at our project as we migrate it to Swift configuration. At the top of our main method, we create a config reader with the two providers we want to use, the environment variables provider and the YAML provider, which reads the YAML config file we already had. When you specify more than one provider, the order in the array represents the priority. In this case, the environment variables will always be checked first, and only if a value is not found there, the YAML file is checked second. And from this point on, the config reader is what we pass around our codebase for reading configuration. First, let's update the log level. We remove the manual parsing of the environment variable and replace it with a type-safe method on the config reader that supports string-based enums out of the box. Next, we'll remove all of the code of manually parsing the YAML config file. And for the listening address, hostname, and port, we'll use the scoping feature, which allows us to handle nested keys without repeating the common prefix. We create a reader scoped to the address namespace, and then read the hostname as a string and the port as an integer. And when we don't need to repeat multiple nested keys, like here for the client timeout, we can still spell out the full config key path by separating components with periods. And last, we update the database URL. Now, notice that we're still using the original hard-coded values from the very first example. They're just used as defaults now, in case we don't override them at runtime. So now we can override any configuration in any of the providers, and our operators can choose where to customize each value. Notice that each configuration key got mapped to the appropriate convention for each format. For example, the log level is an uppercase string log underscore level, used as an environment variable key or name on the left, and the same log level key serves as a way to represent nesting in YAML. So this is what our code looks like now. We simplified the configuration setup of our server app and made it much easier to operate. But we're still doing a lot of heavy lifting that we'll need to redo in the next project. It comes down to the fact that all of our server app's configuration here is actually to configure the libraries we're using, not to configure the server app itself. So this is where Swift configuration helps us again. Because of the separation of configuration reading from the provider, we can use the config reader in our libraries as well. Here's a simple pattern you can use. First, identify an existing type in your library that already represents your configuration. Add a convenience method on it that takes a config reader as a parameter, and use that to extract the individual values. Here is a hypothetical method that could be added to the Vapor, which covers the 3 configuration values we needed to override. It's the same code we saw before, just moved into this method. And as a library author, when you provide a method like this, it puts you in control over the nesting, keys, types, and optionality of all configuration values needed by your library. So for a moment, let's assume that all 3 libraries we're using have a convenience method that takes a config reader. What would our server app look like then? We would update our logging first, then the code to configure Vapor, and then the database driver. So this not only makes our server app simpler, but as the library author adds more configuration options, we as adopters benefit immediately without making any code changes. So even though we started with hard-coded values just a few minutes ago, we now have a simpler yet more powerful way of configuring our server app. And we really took advantage of Swift here with its type safety and expressive APIs. All right, let's do a recap. Let's see if we actually address the problems we started with. Let's start by comparing to hard-coded values. So we now perform configuration updates without a full redeployment, which allows us to react to issues in seconds instead of hours. We use the same binary in both development and production, and those differences are only reflected in the external configuration. And we can quickly tune important parameters like HTTP timeouts without slow deployments. And for the problems caused by manual configuration, we now have a consistent way of reading configuration across apps and libraries. We've decoupled configuration keys from their exact providers, allowing us to specify any key in any provider. And libraries can now fully participate in configuration without coupling themselves to a specific provider. Now, for the next three problems we didn't have time to address today, Swift configuration has solutions for them with additional features, including access reporters, which help us address observability and testability and allow us to log every time a config value is accessed. We have first-class support for secrets, which helps us make sure that we never accidentally log that database password. And when we're ready to stop restarting our app just to apply configuration changes, we can use the built-in support for hot reloading. So this was a very brief look at Swift configuration and how it can help simplify your own projects. But for next steps, I need your help. Try to integrate Swift configuration into your server apps and libraries. Give us feedback on the GitHub repo and on the Swift forums so that together we can arrive at a great 1.0 in the next couple of months. Here's the GitHub link, and happy configuring. Thank you.